Hello, honors algebra students. James and Daddy here. We're recording a review video for you. It's going to be a little bit longer because it is a review video. Ooh, that doesn't really look like a W there. Let me fix that. Oh, there, now it's perfect. Okay, anyway, first of all, we've got graphing linear equations in standard form and slope-intercept form. So, what can you expect on the test? I'm going to give you some equations, and I might say graph it in a certain form. So you've got to be able to manipulate it. Remember that standard form looks like ax plus by equals c, and a must be positive. That's what that means. A must be positive. Slope-intercept form, of course, looks like y equals mx plus b. The y is alone. The coefficient of x is the slope, and the number that's added or subtracted to x is the y-intercept. And of course, it could look like this, and most of you haven't been daunted by that, and I think that's awesome. Anyway, so let's take this blue equation down here, 3y equals 2x minus 9. I tell you what, I think looking at the two equations, I'm going to do one in slope-intercept form and one in standard form. I think this is a good one for slope-intercept form. So I'm going to get the y alone by division. And when I do that, I have to remember to divide all the terms. I have to distribute the division through the right-hand side. So I get y equals 2/3 x minus 3. All right, so I'm going to come on over here, and a negative 3 is my y-intercept, or I should say 0, negative 3 is my y-intercept, right? My slope is 2/3. And so I'm going to go negative 3, 1, 2, 3. Put a nice little point there. And then I've got to rise 2 and run 1, 2, 3. And rise 2, run 1, 2, 3. There we go. All right, so now I can draw my line. I could do a few more points. You know, Lainey likes to do that. She likes to do 5 or 6 points just to make the line look very accurate. And it doesn't really take that long to do that. So, you know, you go ahead and do that. Uh-oh, I missed the point. Oh dear. Okay. That's almost there. Oop, careful, buddy. My buddy just bumped me and that moved my line, but that's okay. What, James? What were you going to say?
That one, it's like not almost covered.
Oh, I'm missing one of the points a little bit? Okay, well, that's tough to do laying here in bed on a sleepy Saturday morning, but we pretty much have it, and I think the kids see how it goes. So we're going to let that go. We should go ahead, though, and label the y-intercept. That way we're telling the reader that we're counting by ones. We're actually telling them enough information that they can figure out what the rest of the graph means. All right, the red one over here, I'm going to go to standard form on. So I'm going to subtract the 5y from both sides. And I know that these are not like terms, so I'm just going to write down negative 3x minus 5y equals 12. But remember, a has to be positive, so I'm going to go ahead and I could either divide by negative 1, which most of you like to do, or I could multiply by negative 1. And that will be fine. I will end up with a 3x plus a 5y equals negative 12. Now, I remember my standard form shortcuts. I know that to find the x-intercept, it will be located at c over a, 0. Or I could just plug 0 in for y and solve for x. That's what the c over a is doing. My y-intercept would be located at 0, c over b, and then my slope is going to be the negative of a over b. So I better go find a, b, c. Easy as 3, 5, negative 12. All right, now that I did write that in the lines. Yes, I did. All right, so now that I've got my shortcut formulas memorized, I'm going to go looking. And I notice right off the bat the y-intercept is kind of ugly. So I'm not even going to worry about finding the y-intercept on this one. I'm going to go for the slope and the x-intercept. So let's find the x-intercept first. It looks like it would be negative 12 divided by 3 will be negative 4. 1, 2, 3, 4. So my x-intercept is going to occur at negative 4, 0. All right, my slope looks like it's going to be negative 3 over 5. And so I'm going to go down 1, 2, 3 and write 1, 2, 3, 4, 5. There we go. Down 1, 2, 3, write 1, 2, 3, 4, 5. And so we have that. And now I can draw my line. Notice that I had the negative slope and the line is going down to the right. Positive slopes have lines that go up to the right. All right. Making it up? You mean making it longer? Well, we make it longer, James, so that we can show the reader what the graph is actually doing. We don't want to just do a little short stubby line because the line goes on forever, so we want to make it look like it's going on forever. And so we use up a lot of the graph. Okay? All right, future algebra student here sitting next to me. Okay, how about systems of linear equations? Well, this is pretty easy stuff. We just have to find out where the two lines cross. So I'll just use my tools here. It looks like on this first equation, looks like a good one to go slope-intercept form on. So I'm going to go 2y equals 5x minus 6. And I'm going to divide by 2, divide by 2, and divide by 2. And so my equation will be y equals 5 over 2x minus 3. So I can graph that equation. So I need a negative 3 as my y-intercept. So 1, 2, 3. And it looks like my slope is rise 5, 1, 2, 3, 4, 5, run 2. And rise 1, 2, 3, 4, 5, run 2. All right, I did that one in blue. I'm going to do this one here in green. Can you tell that that's green? Well, it looks the same to me in this color. Well, James says it looks black. All right, this one I think I'll go standard form on. Oh. All right, thank you, James. He says when he gets closer, you can tell it's green. So hopefully you've got, Sean, you have your nose like right up against the screen. That way you can tell it's green. All right, so I'm going to go standard form on this one. And I'm going to do it in my head. I'm just going to add 4y to each side. So the standard form of this equation will be 2x plus 4y equals negative 36. All right, it looks like the y-intercept's nice and friendly on this one. I think it's going to be 0, negative 9. Right? I'm just doing c divided by b. Sorry, so 0, negative 9. And then my slope is going to be negative 1/2. So rise 1, back 2, rise 1, back 2. Are you wondering why I went up and back first? It's because I know the blue line is going to come down this way. And so I was trying to see where they would intersect. Now, I didn't run into the point where they intersect, so I'm going to go back to this blue one, and I'm going to do the negative of the slope. I'm going to do negative 5 over negative 2. Oops, I'm not in blue, sorry. So I'm going to go down 1, 2, 3, 4, 5, and left 1, 2, and sure enough, they're going to cross right there. So the solution to this system is going to be the point negative 2, negative 8. Now, I still need to draw those lines in. I don't want to be sloppy. No, don't want to be sloppy. Rise back 2. Okay. And I got to get some arrowheads on him because he goes forever, right? Okay. And I'll make him green so we know which equation he went with. And then I've got to do the blue one. And the blue one's going to intersect there. And really, I should make it hit all the points that I took the time to show. So let me make him a little bit longer. That's pretty good. And we'll put arrowheads on her. Why, how do you know it's a boy? I called the last one a boy. I thought I called this one a girl. Can you tell if it's a boy or a girl?
Yes.
How can you tell?
The blue is the boy and the green.
Oh, okay. All right, so anyway. Now I've got another system here. I've got x equals y. Believe it or not, this is in slope-intercept form, where the slope is going to be 1 over 1, and the y-intercept is 0, 0. It's going through the origin. So that'll be real easy to graph. So you say green ones are girls' names?
Yeah.
Okay, so this must be a girl because I'm plotting the points in green according to James, the 5.5-year-old, the man with so much life experience. There we go, something like that. And it should make him nice and long. I missed those points. Her. Okay. And let's see here. Properties, arrowheads, and change the color. Okay, we'll do this one. We'll make this one a boy. We'll do it in blue. X equals 2. This is in standard form, believe it or not. The x-intercept is at 2. Yeah, sure, it's in standard form. Look, ax plus 0y equals 2. So this would be like 1x plus 0y equals 2, or better yet, just x equals 2. It's in standard form. So the x-intercept is sitting here at 2. Okay? And let's see, the slope is going to be -1 over 0. Yeah, it's undefined slope. That means it's a vertical line. So I could go down 1, run 0. Go down 1, run 0. Of course, I could go up 1 and over 0, and I would still get the same line. So it's going to be vertical like that. Let me change the color.
So we know it's a boy.
Okay. All right, so we're going blue and need some arrowheads on this boy. And there we go. And it looks like the solution to this system is going to be the point 2, 2. Hey, it's wearing a tutu right there. All right, very good. Okay, so let's move right along. And here we have systems of linear inequalities. I'm choosing to not show you how to graph linear inequalities by themselves. I figure in the system you'll see the shading and the broken line and all that kind of stuff. So you may have to do it on the test, but I'm not going to put it in this video. All right, so let's see here. We'll make this one the girl, and we'll make this one the boy. All right, so the first equation, or inequality, is in slope-intercept form. So I'm going to go ahead and graph it. Y-intercept is 0, -5. So -1, 2, 3, 4, 5. -5 is right there. And I rise 2, run 1. Count it with me, James. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Very good. Now I need a broken line for this one. Ooh, and I have a green broken line with arrowheads. How lucky am I? Why do I need a broken line? Because it doesn't say equals. It says is greater than. Okay, so make it nice and long. I'll make her a little thinner, pardon me. All right, make her a little thinner, send her on a diet there. Yeah, I'm gonna make it thinner. There we go. Okay, and now I need to figure out which side of the graph I'm gonna shade on. Well, I'm gonna use my test point. I'm going to plug 0, 0 in. So I'm going to get 0 is greater than 0 minus 5. And that is true. 0 is greater than that, than -5. So I'm going to shade the origin side of the graph. And I will shade this one in yellow because I love how it turns out green. So I'm coloring.
Daddy, you know that's yellow, not green.
It is yellow. Yes, it is. There's a reason I'm doing it yellow, though. Do you know what blue and yellow make?
Yeah.
A really bad football team. Oh, beside that, in the art world, they make green. And so what's going to happen, I'm going to shade the other one in blue, and then the answer is going to be the area of the graph that turns green. It's kind of cool.
But that's kind of the team up north at state.
Absolutely. That's why I said the joke about the bad football team. Okay, this one I'm going to do in standard form, and I notice the y-intercept right away is -2. So I'm going to go to -2. Okay, and then the slope is going to be 3 over 4. So I'm going to rise 1, 2, 3, and run 1, 2, 3, 4. Rise 3, 1, 2, 3, 4. You'll see, it's kind of cool. All right, so now I need a solid line for this one because it's equal to, and so I'll go to my solid line here. Make him nice and long, and yeah, make him blue, and I got to put an arrowhead on him. He's got one arrowhead already, so I just have to do the other end, and blue, and there we go. All right, so now I got to do that test point again to see which side I'll graph. I'll put the origin in. Remember, you can put the origin in as long as the line doesn't go through the origin. So I'll get 0 minus 0 is greater than 8. Well, 0 is not greater than 8. Do you agree with that, James? 0 is not greater than 8?
Yeah.
He agrees. Okay, very good. So I'm going to shade away from the origin. So I'm going to shade, oh yeah, but watch this, James. Ta-da! See the green?
Yeah.
Okay, and the rest is blue. So the green region, it's almost triangular, right here is our solution set. Okay, and if you wanted to make that look prettier, you could, but I think you get it bounded by the dashed line and the solid line. It's this entire region right here. Okay, we got one more, and this time I'm doing 3 equations just because of something we talked about in class one time. And so I'll do this first one in red, and this one in green, and this one in blue. All right, this one here is in slope-intercept form with a y-intercept of the origin and a slope of 1 over 1.
No.
And so it's going to look like this. It's going to be a broken line. Where are my lines? All right, so it's going to go something like this. And I'll have to make it thinner and blue. Okay, so properties, let's go thin on a diet, make him blue. And now to test the shading, I can't use the origin, so maybe I'll use a point like, say, 0, 2. Okay, so I'll put 0 in for x, 2 in for y. That is a true statement, so I'm going to shade up. So it looks like my partner got bored and he's leaving us, but that's okay. So now he's prancing around the room like a robot. But did you know my son is fluent in Jawa? Yes, he can speak Jawa. James, will you speak some Jawa for us, please?
Yes.
Go ahead. It's recording.
Houdini!
Okay, very good, James. All right, so now I'm going to, I guess I could be a little closer there. Get closer to that line. Color that in. It's hard to be precise with the airliner. It's real tricky. But as long as you get the idea, it's everything above that line. The line is not included in the solution set. I know this because it's a broken line, because it's not equal to. By the way, I gotta warn you. Oh, excuse me. I was trying to warn you that a sneeze was coming on, but I didn't do it in time. All right. So now I've got this line y is less than 8. Well, that's in slope-intercept form, believe it or not. Y is alone. So I'm going to go to y-intercept of 8. It's going to be a slope of 0. There's 0 x's in the equation. So it's going to be a horizontal line. I thought I chose green here. Sorry about that. All right. So it's going to be a broken line. And where are my lines? I can use green. And it's going to look just like that. Oops, moved on me. And okay, now it's broken. And I can put 0 in. Is 0 less than 8? Sure it is. So I'm going to shade below the line on this one. So let's see, my highlighter. We'll go green.
What do those colors make?
Well, those two don't blend the way the blue and yellow do. But I'm going to shade down here. And I know, what did I say? Oh, okay. Sorry. So we're going to shade all of that. Now I know that I've double shaded this triangular region, but there's a third equation here. And so I've got to go and do him or her. And this one's in standard form with a x-intercept of -2. So right there, and it's going to be a vertical line. It's going to be broken. And so I need to get a vertical line going here. And I'm going to be lazy on this one and just draw the arrowhead in. Okay. And then I've got a shade. Let's see here. See what happens if I do yellow. No, you can't tell. Let me do purple then. Oh.
Black.
Making like a black thing going on here. So I'm losing the whole thing. But you can tell that the part that gets shaded multiple times is going to be that triangular region there. No, it's not going to let me do it. Okay. So I'm going to get rid of that. I really don't like the way that looks. But what I'm going to do is I'm going to erase everywhere that got shaded twice.
Daddy, why is it this going to be sitting there in the middle when they watch it?
Okay. So it's going to be this triangular region. Yeah, to do the shading and have it change colors was going to look pretty ugly, and you weren't going to be able to see. So I'm going to unshade everything to tell you that this is the solution, all right? Because I shaded down below the horizontal line, I shaded to the right of the vertical line, and I shaded above the diagonal line. And so that's this triangular region, okay? All right, try to move this along so it doesn't take too long. Graphing absolute value. Remember, there's two things we have to find. We have to find the vertex, and then there's two slopes that we're going to use when we do it. So the vertex on this one, remember the equation y equals m times the absolute value of x minus h plus k. Oh, I'm sorry, x plus h minus k. And the vertex is located at the negative of hk. So in other words, the h coordinate has to change signs. So the vertex isn't going to be at -1, it's going to be at +1. And notice the k was positive here, it's positive there, so it stays the same. So my vertex is going to be at 1, -3, 1, 2, 3, right there. Okay, the slopes I'm going to use 1/4. I'm going to use 1 over -4, and that will give me my symmetry. Rise 1, 1, 2, 3, 4. Rise 1, 1, 2, 3, 4. Okay, rise 1, 1, 2, 3, 4. And rise 1, 1, 2, 3, 4. So this is going to be a pretty wide V. You probably knew that because the run number was farther away from 0 than the rise number, which causes us to run more than we're rising, and so therefore it will be nice and wide. Okay, got one here, and I've got y equals -2 times the absolute value, a couple more minutes, buddy, of x plus 4 minus 3. So my vertex is going to be at -4, the x coordinate changes signs, -3, the y coordinate does not. Okay, so we go 1, 2, 3, 4, and then down 1, 2, 3. There's my vertex. Now because my slope is negative, my V is going to open downward, but it doesn't change how I do my slopes. And notice I'm not going to simplify that and make them both positive. I'm not going to do that. I'm going to go down 2 and right 1, down 2 and right 1. And then I'm going to go down 2 and left 1, and down 2 and left 1. Okay, that's just my slopes. And so my V is going to look like this. And notice it's narrower than a 90-degree angle. Okay, and there you go. All right, and I really should have labeled my vertices on these. This was what, negative, oh, I think it's -4, -3. I got it backwards. -4, -3. And on this one, it was 1, -3. Okay. All right, one more type of problem. Well, two more types of problem to do. I'm giving you 4 midpoints, or 4 endpoints, and I want you to calculate the slope. and the midpoints. All right, so remember, slope we get by subtracting the y's, subtracting the x's, have to be consistent in our order, and the y's rise to the top. Okay, to get the midpoint, all we do is average the x's and average the y's. That's all we need to do. All right, I'm going to get rid of those because they're in my way, but you should know those formulas very well by now. Okay, so let's find the slope. We're going to subtract the y's, and so I'm going to go -3 minus -2, which ends up being -1. And then I'm going to subtract my x's, 10 minus 6, which is 4. So my slope is -1/4. Okay, that's what my slope is. Now my midpoint, I'm going to average the x's. So I'm going to go 6 plus 10 divided by 2, and -2 plus -3 divided by 2. And that's going to end up being the point 8, -2.5, I believe. Right? -5 divided by 2, -2.5. There you go. Okay, so there's my slope, and there's my midpoint. Okay, I'll do a couple more of those. This one here, let's go for the slope. And I'm going to take 4 minus -4, which is going to be 8. Remember, the y's always rise to the top. All right, and then I'm going to go -6 plus 3. Did you notice I'm going to get a positive anyway, minus a negative? So I just went right for the positive instead of wasting time. And so there, my slope is -8 over -3, or a -8/3. You could tell me. All right, the midpoint. The midpoint, average the x's. I believe if I add the x's together, I get -9 divided by 2. And I average the y's together, I'm going to get 0 divided by 2. Well, that's going to be the point -4.5, 0. Okay? All right, 2 more to do. And so for the slope, I'm going to subtract the x's. So I'm going to get 4 plus 3, which is going to be 7. I'm going to subtract, oh, I'm sorry, that's subtracting the y's. Then I'm going to subtract the x's, and I'm going to get 0. And I'm going to get no slope because I'm not allowed to divide by 0. You could tell me the slope is undefined. That would be acceptable too. All right, the midpoint. Some of you are thinking, can it still have a midpoint? Of course, it's still a line. It's just a vertical line. The midpoint is going to be at 7, because if I average 7 and 7, I know it's 7. It would be silly to do any work for that. I know what it is. And then when I add those two together, I get -1. -1 divided by 2 is going to be -1/2. So there's my midpoint. All right, last one. I've got the slope. I'm going to subtract the y's first, and I'm going to get 3 minus 3, which is 0. And then my x's are going to be 0 minus -4, which is 4, which is 0. This has a slope of 0. It's a horizontal line. Think about it. You know, graph the 2 points. If this is my origin right here, and I go up 1, 2, 3, and if I go -4 and up 3, look at that. I'm going to get a horizontal line going through those 2 points. Anyway, just a little sketch work there, in case I was feeling insecure about my answer. All right, I'm going to add the x's together. I'm going to get -4 divided by 2. Add the y's together. I'm going to get 6 divided by 2. Yeah, see how silly it is to actually do it? If I'm averaging 3 and 3, of course I'm going to get 3. So I'm going to get -2/3 as my midpoint. All right, that's it for the review video. I wish you all well on the test. And Mr. Lawrence would like to say goodbye now. I think his little buddy wants to say something. Okay, I'm not sure what that was, but good night, everybody.